Alright, so we're going to be working on FRQ 2013 number 6. The problem reads, a function f has derivatives of all orders at x equals 0. Let p sub n of x denote the nth degree Taylor polynomial for f about x equals 0. Basically what this means is that if they were asking for p sub 2 of x, you would write out the Taylor polynomial until you got to an x value that had a degree of 2. So for part A, it is known that f of 0 equals negative 4 and p sub 1 of 1/2 equals negative 3, and we're trying to show that f prime of 0 equals 2. So you need to know what the Taylor polynomial formula is, which is sum from 0 to infinity f to the nth power of a all over n factorial times x minus a to the n, where a is the value that your function is centered around. I highly recommend memorizing this formula because it'll really help with these types of problems. In the problem, they tell you what p sub 1 is when x equals 1/2. This represents the first degree Taylor polynomial. So if we write out the first degree Taylor polynomial, we can set this equal to negative 3. So for part A, because it says the function is centered at 0, you can plug in 0 for a. To find the first term, you plug in 0 for n into the Taylor polynomial formula. In the problem, they give you f of 0 equals negative 4. So negative 4 divided by 0 factorial is just negative 4 times 1 is just negative 4. So the first term is negative 4. To find the second term, you set n equal to 1 and plug it into the Taylor polynomial formula. Because they want us to prove that f prime of 0 equals 2, we need to set up an equation. So we know what our first degree Taylor polynomial is. It's the first term, which is negative 4, plus the second term, which is the summation written in purple. So we know that this first degree Taylor polynomial at x equals 0 is going to equal negative 3. After you have set up this equation, you can solve for f prime of 0. We find after solving that f prime of 0 does in fact equal 2. Part A is worth 2 points. 1 point would be awarded for using p sub 1 of x. The other point would be awarded for showing that f prime of 0 equals 2. Alright, so part B reads, it is known that f double prime of 0 equals negative 2/3 and f triple prime of 0 equals 1/3. Find p sub 3 of x, or the third degree Taylor polynomial. We already did half of this work in part A because we found the first term to be negative 4 and the second term to be 2x. It would be a common mistake to think that the second term is just 2 because we just proved in part A that f prime of 0 equals 2. However, we have to remember the Taylor polynomial formula, which is f prime of 0 over 1 factorial times x to the first power. Because we have this x to the first power, the second term is 2x, not just 2. To find the third and fourth terms of this polynomial, you can just use the formula like we did in part A. And remember, the third degree Taylor polynomial doesn't necessarily mean the polynomial has 3 terms. It means that you are writing out terms until you get to an x value that has a degree of 3. In this case, as you can see, the third degree Taylor polynomial has 4 terms. Part B is worth 3 points. You would receive 1 point for the first 2 terms, another point for the third term, and another point for the fourth term. Part C introduces a function h that has first derivative given by h prime of x equals f of 2x. It is known that h of 0 equals 7. Find the third degree Taylor polynomial for h about x equals 0. Alright, so now we're finding the third degree Taylor polynomial of h. So we find the first term of the Taylor polynomial by using the Taylor polynomial formula. Because they tell us that h of 0 is 7, we know that the first term will be 7 because 0 factorial is just 1 and x to the 0 power is also just 1. Remember that the first term is always found by setting n equal to 0 in your Taylor polynomial formula. For the second term, we set n equal to 1 in our Taylor polynomial formula. They tell us that h prime of x equals f of 2x. Because our x value is 0, we can rewrite this summation as f of 2 times 0 over 1 factorial times x. In the problem, they tell us that f of 0 is negative 4, so the second term is negative 4x. To find the third term, we plug in 2 for n in the Taylor polynomial formula. For the third term, we need to find the second derivative of h, which is going to be the derivative of f of 2x. By the chain rule, the derivative of f of 2x is going to be 2 times f prime of 2x. From here, we know that f prime of 0 is 2, so our third term is going to be 2x squared. To find the fourth term, we need to find the third derivative of h at 0. To find the third derivative of h, we need to take the derivative of f of 2x again, so it would be 4f double prime of 2x. F double prime of 0 is negative 2/3, which is given in part B. After finding each of these terms, we can add them together to write out our Taylor polynomial for h of x. Part C is worth 4 points. 2 points are awarded for using h prime of x equals f of 2x. 1 point is awarded for having a correct first term, and another point is awarded for the remaining terms. So overall, this problem really isn't that difficult as long as you know the Taylor polynomial formula. We have seen these types of problems many times, and most likely on the final we will be asked to write some degree of a Taylor polynomial. If you had no idea what you were doing on a type of problem like this, you can still earn credit. As you could see, some of the points were awarded just for writing the first term of the Taylor polynomial. But after watching this video, hopefully you understand how to attack these problems. For more practice on writing Taylor polynomials, here are some problems that I think you might find helpful.